So this session is about innovation, which is really important. There's no development, there's no scaling up, there's no deployment if there's no innovation. And we have some great panelists to speak about innovation. Sit down, yeah, take a seat, yeah. I promise I won't come to you, for any question. Not yet. Yeah. So if we're ready, we're going to start with Kendra. Kendra is the CEO from the Ocean Supercluster, and she will explain, the vision of Canada about, the innovation in the blue economy. Kendra?
Okay, so good afternoon. It's a pleasure to be here. Pierre told me yesterday that he would ask me easy questions because I deal with jet lag. In the afternoon, I had a board meeting at 3:30 this morning. What he didn't tell me, he was going to track me down in the audience and ask me random questions as I was sitting on the other side. So anyway, so we'll see how this goes. So I am not an offshore wind expert compared to most of the people that you've heard speak today, so I will call that out up front. But what I will share is a little bit about what's happening in Canada from an offshore wind perspective. There's been a lot of activity in the last very short period of time, and what the role of the Ocean Supercluster is. So I think, at least in the conversations I've had in the last few days, there may not be a lot of familiarity with what's happening in Canada. So Canada's Ocean Supercluster, oh, sorry, I have control here. There we go. So Canada's Ocean Supercluster is, we call ourselves a cluster of clusters. We are part of a program, federal program. There's been a lot of discussion about the fact that there's not a lot of federal funding or coordinated federal funding in the US, but we do have a federal program where there's 5 what were the innovation superclusters in Canada, what is now the Global Innovation Cluster Program, and our job at the Ocean Supercluster is to grow the ocean economy for Canada. Canada has the longest coastline in the world, the 4th largest ocean territory, and we only contribute 1.6% to our GDP for Canada from the ocean economy. So as much as we have lots of coastline, we do not view ourselves, most Canadians would not view themselves as a maritime nation. From an ocean supercluster perspective, we are in our 5th year. We now have over 500 members. We have a portfolio of about 70 projects, about $360 million, Canadian dollars, in project value. So we have lots and we really invest in technology. And our purpose is really to increase industry investment and commercialization outcomes in technology. So I wanted to just share a few of our projects, I think, that are most relevant to this conversation that we're seeing. While I don't know, I'm not deep into offshore energy, I think I am deep into innovation. That's what we fund. We are cross-sectoral, so that does make us relatively unique in terms of a cluster. A lot of the clusters around the world would focus on offshore energy or aquaculture or. We actually look at how innovation happens across the sectors and where there's commonality to be able to scale more quickly. And so I wanted to mention first our focus on Indigenous. So when we look at where a lot of these projects are looking to go, they are often connected to Indigenous communities. And so in our first round, we had some focus. We had an Indigenous Career Pivot project. And one of the things as we talk about workforce is that when you look at Indigenous workers, they don't necessarily have the traditional experience that we go looking for when we go to hire. And so that really keeps them out of being able to be fully engaged in the job opportunities that exist in something like offshore wind. And so how do we change that? So one of the things that we've got is a matching program. So it looks at skills and it looks like at employer needs and puts them together. But now what we're also doing is what we call our two-eyed seeing project, which is actually looking at how do we increase commercial investment from Indigenous communities into these projects. So this is X-Ocean. X-Ocean is very much, so a lot of what because we have $150 million it doesn't go very far if we're investing in infrastructure. So we really invest in the complementary technology innovation that will be required to make this a success. So as we saw, there's no one on the platforms. This is completely uncrewed, and it all needs to be remotely monitored. And that's going to take lots of technology, that's going to generate lots of data. We're going to need lots of machine learning. There are all kinds of complementary technologies that will be needed to make this successful. So Exocean, what we see is several projects in the uncrewed vessel space. So Exocean is an Irish-based company. They've set up R&D facilities in Halifax, and what they do is they collect data. So there can be ongoing monitoring of sites. They work with wind farm sites all around the world in terms of being able to collect data. And so their project with the Supercluster is to be able to get further out to sea and last for longer from a battery perspective. This one is, I thought it would be good for you to hear from one of our Canadian experts. We tried to get her here, but she wasn't able to be here. So this is Moya Cal, and they actually look for ordnances. So you don't want to set up a wind farm and blow yourselves up. And so they actually do subsea bed scanning. So I think hopefully this will work. There hasn't been a lot of sound all day, so we'll see if this works for me.
Pangeo Subsea was established in 2006. We're headquartered right here in St. John's, Newfoundland. This is the heart of innovation here in St. John's. But we recognized to truly have a global footprint, it was necessary to have operations elsewhere. So we chose in 2011 to set up an office in Aberdeen in Scotland to support our global operations. We've developed a number of unique acoustic technologies that image what's in the subsea bed. So very unique. So just like an MRI that images your organs, we actually image geohazards in the subsea bed and provide that data to our clients to help them plan their offshore installations. So today it's all about data. And we are truly excited with our merger with Kraken Robotics in that it has enabled us to fold in the Kraken products like the Catfish and Sea Vision to offer a broader service delivery to our clients. So now, not only providing data on what's in the subsea bed, but with the Kraken Catfish MinSAS data set, we're also able to see what's on the seafloor with resolutions better than any technology can provide today. One of the biggest challenges we have undertaken with our own Ocean Supercluster project is a commitment to reduce GHG and lower our carbon footprint. We are looking at technology enhancements that speed up our data collection times, and hence reducing the time on our vessel, reducing the size of the vessels, and now going forward, looking at how we can take our people off the vessel and keep them on shore. We've been providing our solutions to the offshore renewable sector for now over 10 years. So it's only natural we play a role in the future of energy as we move away from our dependence on non-renewable energy. Our role as an industry leader is to keep ahead of that technology curve and continue to innovate and find solutions that support our country's push towards net zero emissions. Canada's Ocean Supercluster will accelerate that through the continuation of programs and supports to the SMEs here in Canada that help us scale up and be acknowledged as world leaders. We are more aware of our cross-Canada capacity because of the Ocean Supercluster. We will continue to innovate to find ways of reducing our carbon footprint as we deliver technology solutions all over the world. That's what gets me excited.
Okay, so last couple AeroWind project, that's deep sea inspection. So you can see a common theme here. We're seeing a lot of UAV solutions because of that remote monitoring requirement. And I should have mentioned the Supercluster is a consortium model. And so UAV projects actually fit very well with us because there's typically a customer, there's a vessel provider, and then there's a sensor provider to collect a particular type of data. So it sort of creates a natural consortium that fits with our model. So this is Voyus, and they have a consortium that is trying to improve deep sea inspection, ongoing inspections, again, focused on offshore wind. And then we also have fish tracking. And so, one of the concerns is species movement around these offshore platforms. How do we understand what's happening? How do we understand if we're having adverse impacts, et cetera? And so they have a fish tracking product that is really focused on particularly fixed structures out in the ocean and then tracking movement around those structures. So maybe just a couple of comments on what's happening in Canada. So we are definitely behind in terms of what we're seeing moving around the world, but Canada's working very hard to catch up. I know there were a number of US companies from the East Coast, mainly, that were involved with there was a big announcement from Germany as they look for other sources of energy. And so they're looking at an onshore wind project that would be then focused on hydrogen, production of hydrogen, because Canada has a lot of wind, but we don't actually need our wind. So this is not a grid problem for us. And so there was not really a business case for a lot more investment in wind until we had something to do with it. So the maritime transport need for hydrogen as a source of power really is driving a lot of what is the business case now. So we've seen announcements in Newfoundland, we've seen announcements in Nova Scotia, British Columbia has their Center for Energy, and so there's lots of opportunity now to be able to get engaged, and we will only be able to do that working together and learning from each other, because the speed with which we need to do this, and there was a discussion around licensing earlier, this can't take us 12 years per project. How do we speed up everything without compromising environmental impacts? But we will need people and we need to work together or we just won't be able to get there. So last comment I will make, and then I will give over the floor, because Pierre mentioned this a couple of times. So one of the things the Supercluster has been doing is really looking at where do we want to go? What is our vision for the economy for Canada? I said it was only about 1.6% of our GDP. We want it to be 5 to 8% of our GDP. That would cause it to grow by 5 times. The biggest contributor to that growth is energy. So how do we take ourselves from what is about $8 billion in oil and gas revenue to $100 billion that is mainly going to come from renewables? So that's my job. This was created a couple of months ago. But this is our ambition for Canada, so we're really excited to make it happen. Stop there. Thanks.
Thank you, Kendra. So the next presentation is Roy. Speak slowly because it might be complicated.
I'll speak as slowly as I can, being from New York. Okay. Hi, I'm Roy Robinson. I'm the CEO of Excipio Energy. And Excipio means to capture in Latin. And my team and I, that's what we set out to do, was to take our oil and gas expertise and apply it to originally just to renewable energy, and then eventually we kind of morphed into the whole blue economy. There we go. Now, whenever I've gone to one of these conferences, I say I'm in renewable energy. That's the first thing I get asked. Are you wind? Are you wave? Are you ocean currents? Very rarely am I asked about OTEC or geothermal or solar, but the point being is they see those as separate industries. And as I've gotten more into the aquaculture, I've been kind of impressed about how it mirrors the way aquaculture sees itself as well, because I found out that the people who do the fish don't really talk to the mollusks, who don't talk to the algae, who don't, they're more concerned about who's in their area, and the other ones, they're more concerned about whose investment they're getting, because for 40 years, offshore renewable energy has been fighting for research dollars. So they see each other as competing industries. They don't come to the realization they're part of the same one. Why is that important? Well, we looked at being a title company when we first started out, and we ran the numbers, and one of the things I used to do for oil and gas was run those kind of numbers, and I couldn't make it profitable. We looked at being a wave energy company, kind of had the same problem. Offshore wind and floating wind, you can kind of get there. And if you look up there at the top of that picture there, that's what NREL told BOEM the Gulf of Mexico looks like with regards to potential for offshore renewable energy. It's not very attractive. We took all of them together and put them together in a single platform, and then you get the picture at the bottom. That's important for a couple of reasons. First off, because the wave resource is there in that top picture, but because when NREL analyzed it, they did it as individual. They say economically, a wave energy deployment by itself wouldn't work, and they're correct. When you combine them, it gets a free ride. So we've taken this and we've looked at this from the outside coming in, right? We were the interlopers coming into the offshore renewable space because we came from oil and gas. But basically, oil and gas and power have a linear mindset. Oil and gas, they drill a hole, money comes out. Power companies, they want to have a system, they turn the switch, power comes out. And then aquaculture is also, it's a low risk. They're trying to make one product. To make the blue economy work, you really have to put them all together. Now, this is the slide you're never supposed to put up, and I would never suggest that this is where you should start out, or we're going to do this on our prototype. However, these are just not, it's probably most of them, but not all of the possibilities you can do if you have a large offshore structure. Now, whether it's a repurposed structure from an old oil and gas platform or whether it's a new structure is kind of irrelevant. In this particular case, we kind of envision everything in that blue. That could be a legacy platform in the little blue circle, which you can't really see too well there. And I'm not going to go through all these different things, but suffice it to say that there's ways to do carbon capture or power to fuel plus renewable energy as a hub if you're using a legacy platform. So there's lots of things you can do to repurpose these platforms. Now, our particular technology, and the only thing that our company so far has a patent on, is on this platform itself, not the things you see on it. That turbine up there is somebody else. He's a guy out of Dallas, which if you're looking for something a little lower risk than us, you can go talk to them. That's V3 Technologies. There's several wave energy devices there. There's some ocean current energy devices. Our patent is on the platform that acts like an island. It's agnostic to whose technologies or what you want to put on it. The four-leg design has 12,000 tons of capacity that you can put anything into that will make you money in the particular environment that you are in. As far as the repurposing of the platforms go, one of the reasons why that's important is it is a massive potential, and it's right now kind of a massive thing that's going to waste. We're taking them out at about 200 a year in the US. Globally, that number is somewhere in the same range. But most people don't realize how much steel there actually is in the Gulf of Mexico. Even now, there's still 1,600 platforms out there, 900 of which are producing. There's thousands of miles of pipe that's not being used, it's been abandoned, and it can be repurposed, whether it's for taking fish food off so that you can go out and feed your fish farm that's out there, you can send the food out through the pipes, whether it's using it for the algae production where you turn it into slurry and send it back to a shore processing facility, whether you're using it to export power, because you can by pumping instead of laying a cable. All of that means you didn't have to build that infrastructure. If you had to go out and build it by new, you wouldn't be able to do it economically. There's lots of regulatory hurdles in that particular scenario. You have the status of the old facilities, you have the proposed use, and we're actually in the discussions with Bowman and Bessie, and we're about to start a joint industry project to help clarify what those requirements would be to repurpose here, and we're hoping it to become a model then for uses in the North Sea or in Indonesia, other places where they have lots of platforms. What's this? There we go. And there's the algae and seaweed slide, and I did this because I was invited by people who get into that stuff. The global production has gone up like crazy. But to make this really an economic powerhouse it could be, it's best to do it offshore using the local, whatever the local seaweeds are, and that requires research, it requires investment. But again, if you have a platform like ours, it doesn't have to be ours, but if you have a fixed platform that isn't just a minimalist wind platform, then you can do all these things. Now here's the other thing about why we went with a multi-purpose platform. Offshore wind's focus, and that's the only one that's considered viable right now, is to minimize the cost of the hull, minimize the CapEx, and that sounds like an admirable goal, except it's a self-limiting solution. And even if I make the hull free, I've only reduced the cost of electricity by about 10%. A combined platform, our combined platform, would reduce that cost of electricity 25%, has the advantage of being real, and it goes up from there as the technologies get better, and that's not counting the value-added products like the seaweed, or like power to fuel, or hydrogen, or anything else you want to put out there. So as far as the seaweed goes, one of the things we're looking at right now is sargassum is a massive problem in the Gulf of Mexico and farther down in the Caribbean in particular and on the coast of Brazil. There's lots of plans on how to get rid of it. One of the things you can do up there, you see you can turn to fuel, you can turn to fertilizer. They're looking at other products, but those are probably the main two uses. If you have these offshore platforms that can handle that and are multi-purpose, then you've already got that infrastructure. So once it's there, as other things come up or as other needs arise, you can repurpose them for those uses. Other things you can do off there in the blue economy, fresh water. Here in California, where they're short on water, one of the ways you can export the power is instead of bringing a cable to shore, which they're kind of short on, you can pump large amounts of seawater, you take it onto shore. As it comes ashore, you take a small piece off to run through your desalination, through the membranes. Most of it gets used to generate power. You take the brine and put it back with the rest. Your discharge has only gone up in salinity by about 3%, and you've made power and fresh water onshore in California. The CO2 capture, there's all kinds of different ways you can do that. It's actually easier to do direct water capture than direct air capture. It's also, there's people looking at using chemicals to capture the CO2, which bring it to the bottom or turn it into useful chemicals. And as far as mineral extraction, lithium, all kinds of things you can pull out of, perhaps even that brine stream that you were making as part of making your power and your water in California. But this goes back to that slide that I said that you should never put up. To make the blue economy work, all of us in this room need to work together and look for, this is my waste stream, what can I do with it? Who could use this? Who can help me get this thing to market? Who can help me find something to do that instead of making this a waste, makes it a profit stream? And that way, not only are you more sustainable, you're more profitable, which attracts investment. But that's what we do. And so if you have any questions, I know this was very broad reaching. It was on purpose because I didn't really know what the audience was going to be. But if you have any specific questions about things, feel free to come and talk to me. We also know an awful lot about repurposing facilities and assets, and then how to install fixed wind and a few other things. So, and just one last plug, we're just about to file a new patent on OTEC, which should turn that one into something a lot more attractive than it is now.
Thank you, Roy. Loud and clear. The next one will be Dan. David, sorry. It's your turn.
Good afternoon.
Kendra.
I had to put this up here. This is from our legal department. If you want to read that, I'll give you a copy later. So we play in multiple different markets. We focused originally on oil and gas, and as you'll see from the slides, we're starting to pivot more toward defense, just because that's where the demand is for our products. Our company's fairly small. We're a public company. We've been in business since the late 90s, where we've been producing buoys. We focus on remote and autonomous offshore power and communications platforms. So we're based in New Jersey. We do the engineering, we do the manufacturing there. We also have a sales office and engineering office in Houston. And now we have a network of different groups in different parts of the world to help us sell and market and service our equipment. So these are the products that we have right now that are commercially available. We have other products, but these are the ones that we sell. I'm going to focus today on the left-hand side there, which is the wave energy converter. But just so everybody knows, we also build buoys that's the second picture on the left that work on either on solar or on wind. We also build the autonomous vehicles. This is a company that we acquired about a year ago, just last November. They're based up in Oakland, and they build something very unique. It's a USV that has independent suspension. So it is very unique in the industry, and it actually is very well known for how it can do survey work. It can keep the instruments on it a lot more stable than some of the competitors. And we're actually starting to do surveillance work with it too for the military. And then finally, we also have a subsea battery. It's for shallower waters. It's only rated for 500 meters, but it's perfect for the North Sea. And we developed that because a lot of our customers started out, this is back to the innovation side, our customers started out by asking, well, we don't have really a lot of wave activity where we are, so can you build something else so that we can still have remote power? So that's why we built the solar buoy. And then we started building underwater batteries because they just wanted immediate power. So you can kind of see we're trying to cover the gamut of the different applications. On the PB3 side, that's our most well-known buoy. We have it in multiple locations around the world. It is a true wave energy converter. So the way that it works, for those of you who aren't familiar with it, the yellow piece of it rides up and down the waves. The black part of it that sits below the surface is actually moored. And as this rides up and down the waves, it turns a ball screw, which turns a generator and charges batteries. We have somewhere between 50 and 150 kilowatt hours of batteries sitting below the surface. This is a fairly large buoy. It's about 30 inches in diameter, and it's about 40 feet tall. So 30 feet of that sits below the surface, and that's because we try and have batteries in the buoy where we can actually charge them with the wave energy converter side. We also, something else that sits, that is unique about our buoys is that we can put any kind of communications protocol on top of it. So we have buoys that either use Wi-Fi, they use 4G, 5G in the North Sea, and we also are starting to put buoys offshore that use satellite communications. We can also charge a lot of different payloads. As you'll see in here, it can range anywhere from something as simple as subsea sensors all the way to charging underwater vehicles to also charging all electric trees. So just a little bit about some of the different applications that you can do. We started out by using our buoys in the North Sea. So we were very fortunate. One of our first projects, I guess it was painful and fortunate at the same time. One of our first applications was putting it off the coast of Scotland. So anybody who knows that, that's one of the worst areas you want to put. It's also very good for wave activity because we can generate a lot of power, but it put it to its test. And so we had it out there for 5 months over the long winter, and it performed perfectly. They were using it for things like surveillance. So we actually developed it for oil and gas, and as I'll show you, the surveillance package actually is used by the US military. And so it was one of those unintended consequences, which actually worked out for us. We also, as you can see, we're doing a lot of projects with the WAM-V, which is the Wave Adapted Modular Vehicle, unmanned surface vehicle. It's basically being used for a lot of projects right now, as I said. And then the one thing that was very unique is we were one of the first to actually charge underwater vehicles with our buoys. So that lower left-hand picture, we did a project with another oil and gas operator at the time called E&I. They're Italian, and they basically had all these remote platforms that were unmanned, and they didn't want to have to keep sending a boat out there to go out and do IMR work, inspection, maintenance, and repair. So they actually left our buoy out there, and they had an umbilical running to a docking station, and we charged a Saab Sabertooth. So that way then they could do inspection work out there. It was like an added security blanket that they had there to make sure that nothing was going on wrong. And they actually reduced their carbon emissions, obviously, and their cost by leaving those things out there. So that was a big thing for E&I. And then finally, as you'll see, we're doing a project right now for Enel Green Power off the coast of Chile. So we have a buoy there. It's relatively shallow water. I think it's about 100 meters. Our buoys can handle up to 3,000 meters of water. It just changes the mooring. Doesn't really change the buoy. This particular application, as you can see, is they asked us, there was nothing off the coast of Chile. So Enel Green Power came to us. Enel Green Power is well known for on-land wind and for solar, as you probably all know. They wanted to put the first offshore wave energy converter off of Chile, and they're working with the university there. So basically we send real-time data back to the university, MERIC, the Marine Environment Research Institute down there. So they're actually using that to make sure that nothing goes wrong off the coast of Chile before they put the buoys in there, and also before they put offshore wind. So it's been a great project. We've had that buoy out there for over 19 months, maintenance free. Our buoys are made so that they can go 3 years without any maintenance. And this one is getting close to 2 years, as you can see. And this is our new, I guess, game changer right now, is that we have, on our buoys, we have what we call the Maritime Domain Awareness package. What that, in simple terms, what that is it's got a radar dome on top of it, it's got infrared camera, and it's also got AIS. So what we can do is we can track any vessel within reason that has either the AIS on or off. We can put this out 100 miles off the coast, and we can track anybody from doing IUU fishing to drug trafficking to anything like that. So what we do is we add our package to enhance what already either the Coast Guard or DHS or the Navy already has. And it's the reason that we can do that is because we can track things when there's a marine layer here in Southern California. Satellite doesn't work very well. Also, the radar on the coast here only goes about 8 to 10 miles. And so you need something out there. They can't have Coast Guard cutters and other ships out there everywhere. So you can use our buoy to enhance what they're already doing and add to it. And then we can send data right to the operations center, and they can immediately send out a response team, or you can actually record it so they can use it for prosecuting somebody at a later date. Oh, there we go. And then finally, this is something that we're back to tie it all into offshore wind. So we don't generate enough power, obviously, with the wave energy. Jack may tell you otherwise, but no, we don't generate enough power. But what we can do is we can help out before you have the offshore wind installed. We can actually use either our unmanned surface vehicles to go out and do survey work, or you can use the buoys out there to do environmental monitoring. That's what people are doing right now with it. Before they put the wind farms, you can actually then leave them there if you want during operations. And you can also, finally, what we're trying to do now with some of the ROV companies is to actually put resident ROVs out there. So again, you can reduce the carbon footprint, you can reduce your costs, and actually then you can make sure that people are not coming out there to damage the wind farms or run into the wind farms. We can put them, again, 10 to 15 nautical miles away from the wind farms and actually warn people and then monitor what's going on out there. And that's my update.
Thank you, David. Very interesting. And the next presentation, Jack, when you're ready.
Okay. Thanks for the introduction, and thanks everyone for having me here at BlueTech Week. So my name is Jack, and let me go to the next slide. I received my training from the Scripps Institution of Oceanography as an oceanographer, and currently I'm an MPP fellow at NASA's Jet Propulsion Laboratory, focusing on various coastal remote sensing projects. And I'm also with a startup company called Ocean Motion Technologies, and we make a small-scale ocean wave energy device. And this device was specifically designed with ocean observation and ocean monitoring in mind, particularly targeting a wide range of low-power off-grid applications in the blue economy. And our power solution is to kind of pave the way to build up this ocean of things, or this big data infrastructure for the ocean. And we think there's a tremendous opportunity in the offshore renewable energy space because there's more ocean wave energy on the West Coast alone than 2 times the California annual energy consumption. And the ocean waves actually concentrate solar and wind energy. So they have a higher energy density. Wave is also highly predictable with very low intermittency. So in my opinion, perhaps most importantly, it's also underdeveloped. So if we have a successful project, then the return on investment can also be quite substantial. But like everyone has been saying, the real challenge here, how do we develop cost-effective ocean wave energy devices? So what we need to do is we need to get the basics right, de-risk, validate, and build a viable business in the small scale market first, just like the rest of the renewable energy industry. And then we can scale up to meet larger, grid scale demands. But then the question is, who needs small scale wave energy? So, a few years ago, I was in the field and the ship was really struggling to hold station when we were trying to do our work. And one of the many, many tasks we had to do, and I'm sure a lot of you have done this, which is to do a routine maintenance service for these ocean data buoys, right? And that's specifically for maintaining the power systems. And so it hit me, why are we not using the abundant wave energy for this? And then I realized we could kind of leverage this cross section between clean tech and blue tech to develop wave energy and marine hydrokinetic energy in general. But and this is quite important because once when we can take care of the energy issue in the ocean space, we can reach a completely paradigm for the entire blue economy. And our company was really founded to support this ocean of things paradigm, which will enable key stakeholders and end users to have the capability to quickly respond to changing ocean conditions, whether if it's monitoring overfishing, predicting harmful algal blooms, ocean acidification, weather prediction, long-term monitoring for climate change, and so on. And there are lots of very capable companies and individuals right here in this room who are working on, mostly the first two categories of this picture, work towards kind of building up this ocean of things paradigm. And we have been more exclusively focused on the power component to support the technologies in these first two categories. And also one more thing, I mentioned this yesterday at my other talk. All of this is supported by the US Department of Energy and the National Science Foundation, so we're not trying to sell you anything. We really want to talk to more end users and stakeholders who could leverage this ocean of things paradigm. We would love to hear your user requirements. And I believe that's one of the intentions for many of us here today in the blue tech world, why Matt and Michael have invited the space industry, which is really to get the integration between the space tech industry and the blue tech industry. I think there are a lot of interesting collaboration opportunities there. And to drive it home, in what way is this specifically related to offshore renewable energy? And it has a lot to do with opportunities in co-leveraging and co-developing these existing facilities and resources. And the US Department of Energy has started the Powering the Blue Economy initiative, and the goal is to leverage more use cases in the blue economy to further develop ocean renewable energy, particularly the marine hydrokinetic energy space. So it's to expand beyond the application of just sending electricity to the grid. And on top of that, this ocean of things paradigm can really support all of these co-development and co-generation use cases. And that's in addition to helping monitoring the offshore facilities. So there are also a lot of opportunities of co-leveraging facilities and resources, and it's also very strongly advocated by both domestic as well as international programs, and we can get into it more during the panel discussion. And that's all I have so far. Thank you very much.
Thank you, Jack. Wow, very interesting. Where should I start? There's a word missing, in all these presentations. Biomarine. How do we do the connection with the life, the marine life, using your technology? That's part of also a key part of the innovation. But I have a few questions for you. Kendra, the first question is for you. If they were Canadians, would you invest in their technology?
Sorry, all of them? Any of them? So the short answer is maybe. So I will say I've been admiring the women sitting in skirts on these chairs all day, but I couldn't quite pull it off. So apologies for standing. So yeah, I mean, I think in terms of the types of things that so UAVs I talked about. So I think a lot of your UAV solutions and what you're trying to do are very similar to some of the things that we're seeing. And I think the whole ocean of things. So we have actually done some Internet of Things work under, subsea Internet of Things projects. So I think, how we get to, if you think about United Nations and where they want to go with this idea of a digital twin, real-time digital twin of the ocean by 2030, where you can see it at all different levels depending on the user, we need to get to a place where we can collect all the data to be able to do that. And part of that is really around batteries and being able to actually keep the sensors going and get to remote locations and all of those things that we need to do. So I think well, yours is a bit different. But I think in terms of these two, that's what we're trying to do. How do we collect data? How do we do it with low emissions? How do we do it in terms of being able to maximize battery life? How do we do it in real time? All of those things. Yours, I think, is really interesting because we have lots of platforms offshore Newfoundland, some of which are getting to end of life. And we have a very big biofuels project. So there was a lot of what you said that resonated as well. So I'll stop there.
Actually, it's not biofuel, it's biogas. And when I met Roy, I was preparing my campaign, to deploy the technology where we have invested to transform the sargassum into protein and natural gas. And I came across, his company, and we had the conversation and say, well, that's really clever because it's all about scale. And Jack mentioned that, we do a pilot when it works, we need to scale it up. And for Roy, the real issue is what kind of scale. Sargassum, it's about 20 million tons of seaweed and biomass per year. It means almost, the same size than the entire world production of seaweed. Every year, it's a bloom. And this sargassum is not very rich in protein, 3 to 8%, but it's very rich in carbohydrates. And 6 cubic meter of fresh seaweed could generate, $250,000, in biogas per day. So the real point is, how can we scale up these technologies? And that's why, at the president panel, I was asking about the repurposing of oil tanker, because most of the people I've been talking to in the Gulf area, they say, oh yeah, I'm going to do, 1 ton a year. What's the point? 1 ton a year. We need to go for 100,000 tons per day. And this technology will be able, to be deployed and to scale, to reach that scale. And most importantly, the platform that Roy is mentioning is connected to the land, so we can transfer immediately using the pipe, the gas to the continent.
Yeah, there's roughly 600 platforms that are either abandoned already or about to be. So there's an awful lot of platforms that can be repurposed out there.
And this is the type of project where we need David's expertise as well, because it's all about, monitoring the environment, understanding the data, and what could be done around, the platforms. So I think that this is key innovation, but key innovation also for many purpose, instead of living in silos. And Roy mentioned that, aquaculture, shellfish, finfish, seaweed, we need to work together. And if we want to achieve something, the vision that we mentioned during, the panel about what that was then, talking, representing the Californian government, we need to have a broader approach to the blue economy at large. And we need to speak with one voice. And when it comes, to technology, innovation, data monitoring or offshore and transforming this, or financing, we need to work together. It's essential. During, the last 2 days, we've been talking about blue bonds. That might be the good time for us, to work together and to set up this bond, because that will accelerate. I would like, to see Jack, performing in Canada, in Europe, in Greenland, where we're going to open 10,000 hectares of seaweed cultivation. So we're going to need this type of technology. And I think that there shouldn't be any more borders for that. We need to find, Kendra, we have to move on this, because we need to be able to finance the technology wherever it comes from. And this is very important. What do you think, David?
Well, I was going to say, I'll go back to, we have a lot of experience in our organization. We've been installing buoys and other equipment for 7 to 10 years, so there's a lot of things that can be transferred rather than relearning everything. We can share a lot of that. We work with a lot of other companies that come to us. I was talking to Jack about this earlier. A lot of companies come to us from other countries and say, can we partner with you in the US? Because they're trying to get in the US market, but they don't have the experience that we have. And so they don't have all the contacts we have. We have fabrication shops all over the US that we use. So there's ways that we can share that. And then a lot of companies will come to us including we're working with the Coast Guard and DHS on projects to bring our experience. They have the experience on how to do surveillance and monitor things, but we don't have that experience. But we have the experience with tracking things and sending data from very far distances offshore. So there's a lot of different things that can be, a lot of different user groups, as you said, they can be put together. Sometimes the teams are stronger when you bring all that experience together than when you try and do it by yourself.
But this is why, you know, this type of event are so important, connecting the people. Stefan, instead of be sitting there, you should talk, you know, to David afterwards, grab him and explain what you're doing, because this type of innovation that you sell already, you know, to the most advanced research institute should be, you know, plugged in is technology. So don't forget, you know, to talk to him afterwards. Okay?
Here, I want to add in that Dave is being very humble. I've got about 300 different wave energy companies in my database, of which there are 3 that are anything close to commercial, and his is by far and away the one that has been the most successful. So he's definitely raised the head above the rest of those companies that are in my database.
What is the point of view of Shell about this?
Point of view of Shell, I think, I mean, I'm going to talk about my point of view, which is, you know, yeah, I think we are encouraging gathering more data in general, and I think it's going to be key to work collaboratively on that. I think in the past, sometimes data hasn't necessarily been shared among all the different stakeholders, and I think it's a learning that we have from previous or other places where it actually really helped when we have more data and we share the data and we better understand the impact, so that we can also better articulate those impacts, and it's based on data and not just on beliefs. So, you know, overall, very supportive of having more data collected. I think a question I have, you know, going forward, for instance, if we are considering California leasing, there will be a lot of data that will need to be collected in parts of the permitting process. So curious to hear how maybe some of these newer technology that maybe provide better data, cheaper ways of collecting data, more data, how can we leverage those for those permitting activities?
And well, this is where also you need to take, you know, your role and talk, you know, to these companies, because you wanted to be involved. This is your call. You should be involved, you know, and push forward.
Yeah. I mean, I think to your question and to your presentation, I think, you know, the UAVs, so there's a whole series of different types, whether they're battery powered or solar powered, or what kind of sensors they have on there, what kind of data they're collecting, whether they're on the water, whether they're on the seabed, whether they're under the seabed. There's all kinds of versions of that. But if you can do it in an uncrewed way, if you can leave them out there as long as you possibly can, all of that reduces footprint and cost. I think the eDNA conversation is another interesting one, is that is, you know, targeting, certainly from a Canadian perspective in the Center for Genomics, being able to reduce the cost of environmental data and being able to improve the output.
Yeah, and the de-risking is very important. You're a public company, so you can talk, you know, to your investors and the public, you know, to raise more money and attract them with nice project. But for Roy, it's more complicated because it's a huge project. It's capex extensive, and if you want to go, you know, to an investor and say, "Look, guys, you know, this is the perfect solution." Well, I know the investor because every Monday, you know, I'm sitting in this bloody investment committee, and I try to convince financial people that the blue economy is much more than, you know, a bottom line. And it's complicated. It's very complicated.
It is complicated and it's simple all at the same time. The pushback I get from the people who should know better is that this is too complex, the platform that I have. And my first question when they tell me this is like, have you ever been on an oil and gas platform? I mean, my whole platform has 28 moving parts. Compared to, that's, I think, pretty sure that a single offshore gas separator has more moving parts than that. So it's not complex, it's just not the way that people think about how to do it. They want to focus on, they all want to find the one replacement that they can go out there and we're going to focus on building offshore wind, and that's going to get us there. And it's going to help, but if it isn't profitable enough to attract a lot of outside investment, it's not going to get us where we want to go. My goal, and I'm not going to live to see this, my goal is to see hundreds of these things out far enough offshore that they're out of the sight. I'm an over the horizon kind of guy. Enough of them out there that they act almost like a Great Barrier Reef in terms of their productivity, in terms of the marine life around them and in them. If you've got aquaculture on it, it's just going to enhance that. Plus, you're making all the power and water and anything else that you need that you're sending back to shore. And our platform is designed on purpose to work anywhere in the world, because places like Africa or India or these other places that need that kind of energy and clean water and food, it works there just as well as it works in the Gulf of Mexico, as well as it works in California or New York.
And more importantly, there's many options, to assess the risk. How passionate I am about seaweed. And just to give you an example, the cottony, which is a red seaweed, the price went from $750 the ton, to $3,600 in 1 year because of the demand. So what we do with seaweed is absolutely stunning. We do the only anti-prophylactic COVID medicines, but we do cornea replacements. We do so many very interesting advanced cosmetic and drugs. We do texturizing agents. We do emulsifiers. It's in high demand. Each time you eat some meat, there's algae in it. That's why, the future is combination of these multi-purpose, platform. And wherever, there's oil, there should be, in the future, seaweed. And we're working, on different projects in the North Sea. We would like, the North Sea. I started as an engineer, in the Frigg field in the North Sea, at the top of the derrick. I wish, one day, it could be the largest seaweed field in the world, because this will be pure protein that we will be able, to feed into cattle and for people as well. So it's very valuable. But there's no one solution. There are multiple approaches. And what is key is the global approach also for financing. If we want to reach that point, we need to team up. Norway has been an example, because they use the oil money and convert that into a sovereign fund that is pushing the blue industry. This is a key strategy. Some of the countries I've been working with in the Middle East, they try to get into this direction. But we need more ambassadors like Kendra to explain what a supercluster with enough resources can do and achieve, and demonstrate that this type of entrepreneur, they are worth to invest in. This is very important. I will take a question from the public. Come on. There's no question about innovation? Yeah, okay.
That just sounds to me to be just super cool. So could you possibly expand upon what that could be? What does that include at this nascent stage of even that term?
So that's a term invented by DARPA, and it's referring to essentially the Internet of Things for the ocean, right? So I was talking about it with someone during lunch with Dave as well, and imagine you have the weather app, right? You can open that weather app and you can see the data. You can see the weather prediction. No one has to come to you. You don't need a consultant expertise. You can see the prediction data. That's really simple. That's what we're trying to do for the ocean, for changing ocean conditions, right? And so you can have near real time or live reporting, and as well as edge prediction. Now, to expand on that concept, I think there's a lot of room for growth for all these different companies, right? And for the outer edge of this Internet of Things, imagine it's like hubs and just these satellite images you see of the Earth, of cities and villages, right? At the outer edge, you need nimble, low power data beacon and power hub. And you want to be able to deploy them off the back of your ship or off a C-130. And that provides probably sub-kilowatt power. And as you're going more inward into this Internet of Things, you get to become more like these city hubs. So these are the platforms are provided by OPT or Roy's platform, or the folks sitting in the back of the room I see from Oscilla and CalWave, Dan and Tim, hello. And you know, so basically we at Ocean Motion, our small scale power solution is the last mile for your end user stakeholders. So as they're imagine millions of autonomous vehicles, as you're sending them outward to remote locations, we're your last mile. And then as we're sending our end users inward into this hub of ocean of things, your high power devices are our last mile for our end users. So
David, you wanted to say something?
Just to expand on what Jack was saying. So a lot of times people will ask, well, why are there not more of these devices out in the ocean? A lot of it has to do with early adopters, people that will embrace new technology, that are willing to take a little bit of a risk. We had to get our wave buoy, our wave energy converters field proven. We actually had to go to Europe. Unfortunately, it wasn't France, but it was actually Italy, and we had to go to the UK, and those were the companies that were willing to take a risk. We couldn't find any oil and gas companies in the US that wanted to do. They said, come back to us when it's field proven. Now that it's field proven, we have certain companies that are looking at our technology, which is great. That's great for the future growth of our business. The other thing is real estate. We could not get back to California. We're trying to put buoy off the coast of California in the next year, and a lot of it is it could take 6 months or more for a permit, and that's at least 6 months, I've heard. So it's one of those that it could grow faster, but those are the things. It's finding people that will help your small company grow with the investment, with willing to take a risk on the new technology, and also having permitting and getting that approved.
I want to add something to that. I said this was the very first renewable energy conference I went to in 2016, and it was somebody talking about putting their wave device up there in Northeast or the Pacific coast. And I said, well, why don't you come to the Gulf of Mexico? And they're like, oh, what the resource down there is not good. I said, you're trying to test and prove that it works. I said, leave it out there till a hurricane comes. You get all the wave energy you need, But it's the point being is that down there, the permitting and the cost of doing it will be a fifth. And the permitting down there for something like that is very straightforward and very simple, because the people there don't see it as a threat. They're not worried about you destroying their environment. And they want more energy infrastructure out there, renewable or oil and gas. The whole Gulf Coast people there love this stuff and want to see it. So they'll invite you in, right? So yes, you still have to find the financial backers. But if you have a device that you want to test, I love California, love San Diego, and I'm from New York. This isn't because I'm living in Texas. If I was going to develop a new device, I'd be looking to do it in the Gulf.
And this is where you invite.
Or Nova Scotia. They're still cheaper than here.
And this is where. This is where you mentioned your conference next year, OTC?
Yeah, the OTC is, the Offshore Technology Conference is the biggest offshore technology conference in the world. It peaked in 2014 at 110,000 people. Obvious with COVID, it dropped down quite a bit. We're expecting it to go back to about 40,000 this year. It's thought of as an oil and gas conference. It has never been just an oil and gas conference, though for obvious reasons, that has been the majority of its focus for many years. But since about 2015, it has been shifting. And right now, it's about 1/3 of the papers and sessions are going to be on renewable energy and the energy transition. We'll be there. Greentown Labs, which is where I office out of, is going to have a booth. There's actually an energy transition pavilion. I'm hosting a couple of panels and sessions, and I have 3 papers in there on renewable energy. So if you're looking for some place to go and see all of the offshore technology that you need to build this stuff, that's the place to go. It's the first week of May every year. And if you want to put in papers for next year, let me know.
So that was your takeaway message. David,
Sorry?
your takeaway message.
Well, I think that it's great to see all the different groups that are developing things and all the new technology. I mean, I think it's really this whole room, like you said, it takes a group to support it. We wouldn't be where we were if we didn't have supporters from, and there's several people in here that know that they've helped us get to this point. So I would say that the takeaway is make sure, as I think Matt even said at the beginning of this, make sure that you network here. It's a smaller show, but I will say I've had more good conversations here than I've had in some of the larger shows. because people don't have time. People are here for a reason. So I would say use your network. That's what I've learned over the last couple of years. If you can't do it, there's somebody in this room that can do it.
Absolutely. Jack?
Yeah, I just want to echo everyone's message. Yeah, I think this is a really great event, and there are a lot of opportunities where people can collaborate. And I think this is especially seen between the intersection of the space industry and the BlueTech tracks, where a lot of the space data can really be validated and cross-referenced with things we collect in the ocean. So I personally, as both someone who works in the space data industry as well as in BlueTech, want to see more of those collaborations happen, and hopefully more of these projects will arise from this event.
And Kendra?
Yeah, so just to clarify, I said Nova Scotia because they have a sensor bed project. You're welcome in all of Canada, but that was why I mentioned that one in particular. That you can look at the Stella Maris project. The more investment that we can attract to all of these different solutions, the faster that we can move. And so this audience has a huge responsibility for continuing to raise awareness. I am always surprised by how much there is a lack of awareness as soon as you get a little bit outside of the circle of the blue economy. And so we really need to invest in all the solutions that might work and get them all going and co-create and collaborate and do all those things, but raising awareness so that we can get more investment in this space is absolutely crucial to the success of where we want to go as a planet and as a people.
Thank you, Kendra. As we conclude the session, please join me to thank all the panelists.